Hello students, this is my second video on the topic of pharmacology of drugs acting on central nervous system. From the first video of this topic, we have learned about what is the neurohumoral transmission, fundamental process, and the mechanism of neurotransmitter release. Now we have to learn about what is the fundamental mechanism process of neurotransmitter release, which is action potential. This is the change in electrical potential associated with the passage of an impulse along the membrane of a muscle cell or a nerve cell. There are some topic regarding this total topic. Look at this graph. There is this stage is resting potential. After that, the slope is depolarization state, and after that the slope is repolarization state, and through hyperpolarization then the slope is remain in resting state. So in every single neurotransmitter transmission process, this electrical potential are associated. So now we have to know about these 5 stages are associated with this action potential. In resting potential, sodium and potassium channels are closed. Sodium rushed into the cell and potassium are concentrated inside the cell. Then the potential difference is minus 85 millivolt. Next, depolarization state. In this state, the sodium channels open in response to a stimulus, and sodium rush into the cell according to the dictates of diffusion, and final potential differences will be occur plus or positive 30 millivolt. Next, repolarization state. In this state, sodium channels close and potassium channels will be open. Potassium ion rushed out to the cell according to the dictates of diffusion. Potential difference is to slightly below, where the potential difference will be minus 85 millivolt. After that, hyperpolarization state. It is a change in a cell's membrane potential that makes it more negative. It is opposite of a depolarization state. It inhibits action potential by increasing the stimulus required to move the membrane potential to the action potential threshold. And lastly, resting condition re-established furtherly, where sodium and potassium ions channel are closed, sodium potassium exchange pumps moves, and sodium out and potassium in will be occurred, and the resting potential difference will be minus 85 millivolt. Now we have to learn about the classification of neurotransmitters. Depending upon chemical nature, we can classify neurotransmitter in these 3 steps or three basic chemicals. Firstly, amino acid. In this type, the neurotransmitter of this group are involved in first synaptic transmission and are inhibitory excitatory. Both action will see. Example, GABA, glycine, glutamate and aspartate. Next chemical is amines. Amines are the modified amino acid. The neurotransmitter of this group involved in slow synaptic transmission and are inhibitory, excitatory. Both action are used by this group. Example are noradrenaline, adrenaline, dopamine, serotonin and histamine. The another is the one which do not fit in any of these categories. Example, acetylcholine and nitric oxide. Now, this is also a classification of neurotransmitter which is depending upon function. Excitatory neurotransmitter. Excitatory neurotransmitters function to activate receptors on the postsynaptic membrane and enhance the effects of the action potential. Example, glutamate, acetylcholine, histamine, dopamine, norepinephrine, also known as noradrenaline and epinephrine. Next is inhibitory neurotransmitter. By the name, we can already understand what does it want to mean. Inhibitory neurotransmitter function to prevent an action potential like gamma aminobutyric acid or GABA, serotonin and dopamine. The secondly, neuromodulator. Its function to produce slower pre or post synaptic responses. In this group, the neurotransmitters are dopamine, serotonin, acetylcholine, histamine, and norepinephrine. The another class is neurohormones. Releasing hormones from hypothalamus are mainly grouped into this category. They are oxytocin, vasopressin, also known as antidiuretic hormone.